Electricity. When people think of electricity, they usually think of dynamic electricity, when there are negatively charged particles called electrons flowing through a conductor. This flow of electrons is known as current, and the voltage is the force that puts the electrons in motion, sort of like the pressure that pushes a fluid through a pipe. A simple battery is made up of two parts, separated by a thin barrier. Each of these two parts contain atoms with opposite charges. The positive side of the battery has atoms with less electrons, and the negative side of the battery has atoms with more electrons. In nature, things want to be in a state of balance, a form of equilibrium. The electrons naturally want to move where there are less electrons to achieve a balance in nature. However, the electrons inside the battery cannot do this because of the thin barrier that divides the two oppositely charged sections of the battery. To allow the electrons to flow to the positive side of the battery, we can use a conductive wire to create a new path for the electrons to flow through, creating an electric current through the wire. The voltage comes from the electric force that naturally wants to bring the opposite charges together to restore balance. This electric current passing through the wire can be used for practical things like turning on a light bulb. As long as the current passes through the light bulb, it will continue to glow. But when both sides of the battery have the same amount of electrons, the battery will have achieved equilibrium and die. However, the problem with this circuit is that it's not exactly true. You see, things in nature can often be messy and unorganized. What's going to stop all of the electrons from flowing through the wire at once? Too many electrons flowing through a conductor can result in an electrical short, which can damage components and destroy connections. What a circuit needs is some sort of resistance to limit the amount of electrons that can flow through the wire. This component is called a resistor, and it will regulate the flow of current by adding resistance to the electric circuit, sort of like the friction you feel when you push a heavy object on a rough surface. However, a drawing like this is a little too detailed for designing schematics, so we can reduce each electrical component to simple abstract symbols. The voltage from the source is measured in volts, the current through the wire is measured in amperes, and the resistance is measured in ohms, which is represented by the uppercase Greek letter omega. In this schematic I just drew, you will notice that the current is moving in the opposite direction from the previous animation, and that's because the conventional current flows in the opposite direction of the electrons. You can blame Benjamin Franklin for this mistake, as he thought electricity was like a fluid, so when something was positively charged, it had more of something instead of having less of something. But I mean, could you blame him? He was experimenting with electricity in the mid-1700s, way before the atom and the electron were discovered. He had a 50% chance of getting it right, and unfortunately chose the wrong one. So you're just gonna have to put up with this mistake, because everyone draws it in this direction, and it will never change. Anyway, in the year 1827, a German physicist named George Ohm would discover one of the most influential laws called Ohm's Law. Ohm's Law is an equation that describes the relationship between the voltage, current, and resistance in an electric circuit. As the resistance increases, the current decreases, and as the resistance decreases, the current increases. Using Ohm's Law, we can calculate how much current is flowing through an electric circuit. Suppose we had a circuit with a voltage source and resistor. If the source is 5 volts and the resistance is 100 ohms, how much current is passing through the wire? With a little algebra, we can manipulate Ohm's Law to find that the current is equal to the voltage divided by the resistance, which gives us 0.05 amps, or 50 milliamps if you multiply the current by 1,000. Easy, right? Now let's try a real-life problem. Suppose we had the same circuit, but now with an LED. If the source is 3 volts, and the current passing through the LED cannot exceed 20 milliamps, how much resistance is needed to prevent the LED from being destroyed? Well, if we rearrange Ohm's Law to find the resistance, we will find that the resistance is equal to the voltage divided by the current, which comes out to be 150 ohms, which you can buy online to build the circuit in real life. In my next video about electric circuits, I will talk about what happens when you have more than one resistor in an electric circuit. And as always, thanks for watching, and I hope you learned something new. Peace.